Okay, in this video we are reviewing dividing using the laws of exponents. So we're going to simplify polynomials that involve division. We're going to start with a small one like we did with multiplication and work our way up to some more complicated ones. Now these will include multiplication and division in the end, but we're going to be combining them, but that's what you're expected to do, so we're working our way towards the level you need to be at on the test. So the first one we're going to do is going to be 7y to the fifth divided by 5x squared. Okay? What can you simplify on this one? Take a look at it. The thing you should be recognizing right now is you can't simplify anything on this one. You have to be able to identify when your problem is completely simplified. 7/5 is in simplest form as far as the fraction. It's an improper fraction, and that's the way we leave them in algebra, but 7/5 is simplified. You can't subtract exponents here because they aren't common bases. It's y to the fifth and x squared. The variables show up one time only, so that one is actually simplified, and you need to be able to recognize that. Alright, let's try another one that can be simplified. Let's look at 10m to the fifth n squared divided by 4n to the fourth. Okay, we're going to start with the integers, just like when we multiplied. 10/4 you have to reduce, and like you learned in 6th grade with the fraction. So you would divide the 10 by 2, and you would divide the 4 by 2. I picked 2 because it goes into both numbers. So that is actually going to be 5 halves. And 10/4 and 5 halves are equivalent fractions. This is the only m in the expression, so there's nothing to simplify it. I'm just going to leave it as is, m to the fifth. And then I have 2 minus 4. Remember, when we have a common base and we're dividing, we subtract, so we have 2 minus 4 gives us n to the negative 2. I'm sure you're recognizing right now, thinking you can't have a negative exponent, so we're not finished. So our final answer is going to be 5 halves m to the fifth. I take the reciprocal of this to make the exponent positive. I put an equal sign here. I want you to realize these are equivalent expressions, just written different ways, and this one is simplified. When they're simplified, you see each variable one time, your fraction is reduced, and you have no negative exponents. Okay, so do you want to try another one? I'm going to keep getting a little bigger, and this one isn't just a little bigger, it's a lot bigger. We're going to have negative 8y x to the fourth times negative 2x to the fifth y squared, and that's all going to be divided by negative 6x to the fifth y cubed. Okay, so you have this big crazy thing going on. We're going to start by multiplying across the top, and organization is important. So if you look at the problem, make a plan and go from there. And I'm saying to myself, okay, I'm going to multiply across the top. The bottom's already simplified. Then I'll go into the division after I finish the multiplication. So I have negative 8 times negative 2 is positive 16. Remember, I always start with integers. I'm going to do x first because I like to go in alphabetical order. X to the fourth times x to the fifth. I add exponents. That gives me x to the ninth. And then I have this y times y squared. Don't forget there's a little 1 there. That gives you y cubed. Nothing's changed on the bottom, so I'm just going to rewrite it. Okay? So now I've got the top simplified and the bottom simplified. I'm going to go ahead and divide. 16 divided by negative 6 is a decimal, which means I just have to simplify the fraction. Again, these are both divisible by 2, and that's how I'm going to simplify the fraction. It's going to end up being 8/3, which is an equivalent of fraction to 16/6. Now, I'm going to take x, the x's, and simplify them. I simply subtract exponents. X to the 9th divided by x to the 5th is 9 minus 5. It leaves me x to the 4th. And remember, when you use a subtraction method like I am, you always write it on the top and at the end adjust if you have negative exponents. Okay, y cubed divided by y cubed. When you subtract your exponents, you get 0. Do you remember what anything raised to the 0 power is? It's 1. If I write times 1 in here, it doesn't change the answer. And so your final answer is actually 8x to the 4th over 3. And that's the final simplified answer. Another thing to realize over here with this y cubed over y cubed, anything divided by itself is 1. So y cubed divided by y cubed would make sense. This down here goes into this one time. Okay, I'm going to give you one to try on your own, and then I'll give you the answer so you can see how you did with it. Let's get a new layer so I can write. Okay, 4x y to the 0 divided by 8x to the negative 2 y to the 0 times, multiplications on the bottom this time, 6x to the 5th. Go ahead and pause the video, try and work this one out on a piece of scratch paper, and then we'll see how you do. Okay, there is something that I'm going to simplify when I do this. I'm going to simplify the top and the bottom, and then I'm going to divide, because there is something to simplify here. You all know what y to the 0 is. It's 1. What you got to remember is that 0 does not apply to the 4 and the x. If parentheses were present, it would go to everything inside the parentheses. But in this case, the 0 only goes to the y. That makes that 1. So I have 4x left on the top. Down here, I have 8 times 6, which is 48. X to the negative 2 times x to the 5th. Negative 2 plus 5 is x to the 3rd. And then y to the 0 is 1. So that's just a 1, and I don't need to write it down. So here I have a fraction that can be simplified, and I still have 2 x's, so I'm not done working. 4 over 48. 4 goes into both numbers, so we're going to divide each one by 4 to simplify the fraction. That gives me 1 over 48 divided by 4 is 12. So I have 1/12 instead of 4 over 48. X to the 1 minus 3 is x to the negative 2. When I use the subtraction, it gets written up there. Then I'm going to go into my final answer, which is going to be the 1 remains on the top, and I have 12x squared on the bottom. You can't just have an empty numerator, so the 1 has to be written out in that case. Okay, so there's your final answer, and this is about as tough as they're going to get. You might throw an exponent in on the test. As long as you stay organized and work through step by step and don't try and take shortcuts, you should do really well on this.